Hello everybody. Today I'll show you how you can use shape grammar to do patterns in your placement of the procedurally placed meshes and how you can utilize the already spawned meshes with grammar to spawn additional meshes like the railings and the chairs inside this train. So let's start. First, let's start with a simple example to understand how grammar works. So let's hide this train for now, and let's start with a simple example. So I have prepared a simple blueprint, which includes a spline inside the blueprint, spline actor, and the PCG component. So when you create your blueprint, so right click, create blueprint class, make it an actor, and after you create the blueprint, here into the default scene root, add a spline component, this spline, and a PCG component, this one PCG. And for the PCG, you need to create a graph in order to connect it here. This field will be empty by default. So here is how the PCG and the blueprint will look like. And when you right click in your content browser, find the PCG tab, create PCG graph, create an empty PCG graph and call it, in my case, it's grammar tutorial. So I already have this graph created. Connect it to the PCG component in your blueprint. This graph attribute here should be set to the newly created graph. Compile and save. And after you place the blueprint in your level, like this, I currently have a simple setup, but if we delete everything, you have in your level the blueprint with the spline that you drawn, and you will be able to change the size of the spline by selecting the point and moving it left and right. So let's start with creating a simple grammar setup so I can explain to you how grammar works. So let's open the PCG graph. Let's right click, get spline data, and our spline data will be filtered from our actor, the self actor, which means the blueprint that we use this PCG graph in. So let's drag out of this out pin and create subdivide spline node. And this subdivide spline is what is used to apply the shape grammar rules. So we need to have some modules. So let's go into some folder. So here are a couple of meshes that I prepared for the outside of the train. And the important part for now for these meshes is that they have their pivot set up in the middle. And this is the default way of working for grammar. And if I open the original meshes from this pack, for example, this one, you see that the pivot is in the right side of the mesh. So I'll show you later how you can fix this issue. It's not an issue, but different workflow in this case. But just for now, in order to understand how grammar works, I have prepared 3 meshes with the pivot set up in the middle. And again, later I will show you how you can work with meshes that are not set up this way. So the default ones from this pack with this modular metro train. So let's open again our graph and let's set up a couple of modules. So here into this subdivide spline node, we can add modules into this module info. So let's click the plus sign and we'll create a symbol called, for example, wall. The size will be 150. It will not be scalable for now. And let's create another module, which will be with a symbol window. the size will be 150 again, and it will not be scalable again. And I'll accept incomplete subdivision because my spline will not always be covering the exact size of my individual parts of the shape grammar that you'll be using. So make sure that this accept incomplete subdivision is clicked and set up your modules like this. And I'll actually set up my modules in a different way later, but just showing you the default options that this subdivide spline node gives you. So when you subdivide spline with this node, let's for now do an attribute filter, just to show you what it does. So in this attribute filter, I will check if the symbol attribute is equal to constant of, in this case, wall, which is the first one. So inside the filter will be all the wall generated segments, and outside the filter all the window generated segments, because we only have two types right now. So let's drag out of this inside filter and do a static mesh spawner. And for our static mesh spawner, let's create a mesh entry and let's connect our external wall, the one with 150 units wide, because this is the size that we set up for our module here, 150. And now let's copy this static mesh spawner, and now let's connect the window. So let's save this and let's look into our level and let's see what will happen and how it will work. So first we are getting a spline which has 2 points, the beginning and the end. So if we inspect this node with the A key, you'll see that it only has 2 points. And if we inspect this subdivide spline node, currently it doesn't return anything because we don't have this grammar string entered here. So with this grammar string, using the symbols that you set up here into the module info, the symbol field is the name of the symbol that you want to use. And this symbol can be used with a couple of different options that this grammar, shape grammar syntax allows you. So the simplest thing is just to write the name of the symbol. So if I write wall, you'll see that it generates a single point, which is having this attribute symbol set to wall. So if I type comma and then window, after the wall segment, it will add a window segment. And you can group nodes with the square brackets. So I'll add an opening square bracket in the beginning and closing square bracket at the end. And then add a number, for example, 3. And in this case, you'll see that it will create a group of these segments, so wall and window. This will be one group and it will repeat it 3 times because I added 3. If I put 2, it will repeat it 2 times. And if, for example, I don't use these square brackets, I use the curly brackets instead, this means that it will pick random item of all that are in these curly brackets. And let's put 3 at the end again. So it will put a random item, either a wall or a window, 3 times. So the first time it used a window, then a wall, and then again a window. And if we change this seed value, you'll see that each time it will pick randomly a different type of item, but it will always be 3 times because this is how much times we told it to repeat it. And if you put a star for the repeat value, it will repeat it however times possible for the size of your spline or the area of the spline which is not used by other modules. And you can see that it automatically fills the spline from the beginning to the end. And one important note here, you can see that here at the end, it's not actually filling to the last place which my point is set up. It's leaving some gap because the size of this object is not enough to fit into this area. And this is where the scalable options come into play for all the modules that you set up for your subdivide spline node. So if you mark scalable for any of the nodes, it can change the size of this node in order to fill the entire space of the spline. So let's leave this scalable for now for both the window and the wall. Or actually, let's do it only for the wall. So the walls can be scaled, but the windows will always stay the same. Because let's say we don't want the shape of the window, this rounded corners, to be distorted or something like this. Or later we can use another window which has a circle shape here at the bottom, so we don't want to distort it. So that's why we'll just scale the wall segments. And this setup works for 2 meshes, but if we add a third one, we need to filter again for the different type of segment, because we'll have now everything that's a wall goes inside the filter and everything that's not goes down here. But if we have a third type, we need to filter here again if it's not a wall but if it's a window, and then we'll have a third type here, which will be, for example, a door or something like this. So this is not a very good way of working with grammar, filtering the results for every single type. So what you can do instead is I'll leave a single static mesh spawner. If you remember in the previous tutorials where we used match and set attributes, for example, for the level instances, we can make Unreal set up all the points in a way that they will have the mesh attribute saved for each point, and this mesh attribute will be used here instead of adding the mesh entry manually into our static mesh spawner. Let's delete this entry and let's change the type to a mesh selector by attribute, and our attribute will be called mesh. And now, instead of setting up our segments, our modules into the subdivide spline like before, I'll delete this and I'll mark module info as input. So we'll have this input for the modules info. And I actually created enum type, which you can see right here. So this grammar item, struct, sorry, not an enum, but this grammar item is a struct which is created with a mesh, symbol, size, and scalable variables. So when you create a struct, so let me show you how to create it. Right click, search for structure, and let's call it struct tutorial. This tutorial structure, it has by default just a single Boolean variable inside, so this can be our scalable, which is Boolean. So we can add another which will be mesh, and this should be static mesh type, static mesh object reference. Then another variable by this add variable button right here. It will be size, and the size will be a float value. And then lastly, a symbol attribute, which will be string. And let's change the order a little bit. The scalable will be at the end. Symbol will be the second one, let's say. So let's save this, and into the default values, make sure that your size is not set to 0, because if you forgot to set up your size and you leave it as 0, you can crash the engine, because when it tries to split the spline for all the symbols you have, if the size is 0, it will try to place infinite number of segments. So make sure that the size is something reasonable, for example 100, and I'll put a default symbol item, and scalable, let's say, by default will be true. So let's save this. And let's go back to our PCG graph. So right now, we can have a parameter in our graph. So I currently have one created already, but I'll delete it. So we can create a parameter for our graph, and we'll call it, for example, modules. And we'll change the type to this, how was it called? Struct tutorial. Yeah, str tutorial. So I'll change it to an array because we'll have multiple modules set up right here. And let's create 2 modules or 3 modules so we can show what's the benefit of having this approach, because it was working fine with 2 modules before, but with more modules you need to have this better structured approach. So here let's go into our pivot center meshes that I created earlier, and let's connect them. So this will be wall 150 units. Let's connect the other one, which will be wall 2, and it will be 200 units the size. It should correspond here to the size of this static mesh. And lastly, this will be window, and it will be again 150 units, and I'll connect this window here. Let's save this, and right now if I right click into my PCG graph and search for this modules parameter that we created, you'll see this modules is available to be set up. So again, from the graph parameters section here, create a new parameter, call it modules, and add 3 modules which are of the new type of the struct that we created for our grammar objects. So back to our subdivide spline node, make sure that you have module info as input checked here. And if we connect our module info, you inspect the subdivide spline, you'll see that we start to split the spline into modules. But we need one additional step, which will be to use the match and set attributes. If you remember from previous tutorials, it will match from this data that we create for the subdivision spline with our modules. It will match by an attribute. It will find the same attribute into the other set, and it will match all the other attributes with the data. So the attribute that we want to match is this symbol attribute. So write symbol into both the input and match attributes. Connect the points that you generate from the subdivide point to the input of this match and set attributes, and the modules into the match data. And right now, if I connect my match and set attributes to our static mesh spawner, you'll see that it works great. So now let's see that how it works with 3 modules instead of 2 like we had before. So I can add wall 2, which is our other wall piece, and you can see that now we have a random module from our 3 different type of modules repeated however times possible because of our star here at the end. So because of the curly braces, it's a random item of the 3, and because of the star, it's repeating it till it fills the spline. So let's see what else we can do with our grammar syntax here. So as you remember from before, if you use a square bracket and then put, for example, wall 1, then it was just wall, then window with a comma. So this is a block that we can create. Then let's create the other block, which will be wall 2, then window. So now we create first one of the blocks, which is the regular wall and the window, and second block will be the second wall, which is the 200 units wall, and then the window. And we can then put the curly braces outside this, and let's put the star at the end so we repeat our modules and they are not so stretched like we had it before. So now, because our curly braces have as items here groups of 2 modules, it will pick either this entire group or this entire group when it tries to place objects into the scene. So in this way, you always have a wall then window repeating, but sometimes the wall will be the first type of wall and the other times it will be the second type of wall. And that's why here at the middle, you can see we have the wider wall. And if we change the seat, you can see that in different places, it will pick different groups, which we had here. So this is a great way to combine different features. Another feature you can use, for example, is, let's say you want to place wall 2. Let's delete everything. So you want to place wall 2 however times possible. But if you cannot fit a wall 2, you want to place a regular wall. And you can do this with this smaller and greater signs. So use them like a tag in HTML tags or XML tags if you are familiar with such languages. But encapsulate your modules with this less than and greater than signs, and everything in between with commas, the list of all the objects. It will try to place the first one if possible, and if not possible, it will place the next and so on until it finishes the options. And you can see that here it always places the wider wall, which is our wall 2 module, into our level. So you can see this one, this one, this one, this one, and this one are the wider 200 units wall. And just this one is the smaller one because it will always first try to place the wider wall. And if not possible, it will place the smaller wall. So this is another great feature of the syntax with grammar you can do. And one other thing that you can do is, let's say we'll group this into a single group and we'll add the plus sign at the end. So this is similar to the star. So it will repeat all the objects into the scene until the spline ends. But the difference between this and the star, plus means that it will always place at least one of these objects that you specify here. So another feature that you can do for the random placement, for example, if we put wall, then wall 2, then window, and we put the star sign, so we fill the full area of our spline, you can see it will place randomly an object from each type each time it tries to put an object. But if you put a colon and then a number for each object, for example, for the wall will be 5, for wall 2 will be colon 1, and for the window will be colon 1 again. This means that it's 5 times more likely to pick the wall instead of the wall 2 or the window. So if we change the wall to 1 and window to 10, for example, it's 10 times more likely to pick the window. So with this colon syntax for each item, inside these curly braces, this will only work inside the curly braces because it's a random chance multiplier, let's say. You can set up how likely is for each object to be picked. So this is all for the syntax, and it looks simple, but when you combine all these different types of syntax, and you can also do other things. For example, you can get grammar as attribute here into this subdivide spline. So let's copy this grammar that we have here. So, and let's add an attribute here, add attribute, and this attribute will be called grammar. Let's connect it. And right now, here, when we pick grammar as attribute, the attribute we'll use will be called grammar, because this is the attribute name we created here. The type will be string. And here, let's create constant. And the constant will be string with the value, the same value that we have before. Let's connect it, and it works the same. But what is the purpose of doing this? The purpose is that you can edit this attribute based on some conditions. For example, let's change this to just wall and then the star sign. So we'll only place walls, but let's do some conditional work with our nodes right here. Let's do a spline sampler. So for this spline sampler, let's do subdivision 0. So it will pick the first and the last point, as you can see here, the first and the last point only. But we want this spline sampler here into the attribute section to compute the distance. And if I scroll back here, so I have marked this spline sampler, click the A key to inspect it, and you see that for each point it will output what is the distance from the beginning of the spline. So right now the distance for our end is 1000 units and 1170 units. So in order to pick our last point right here, let's do an attribute filter. Let's do target attribute of $ index, and the index will be equal to an integer value of 1. So equal $index, use constant threshold, mark as true right here. The type will be integer and the value will be 1. So inside this filter is just our last point. If I inspect this, you'll see that it's just our last point with our distance of the size of the full spline. So let's check if a value is greater. So let's say the value we want to check is the distance. And again, here into our spline sampler, in the attributes, we are computing distance and saving it into the distance attribute called distance. Then we are comparing this distance with a value right here of, let's say, 1000 units. So here, let's do a branch node. So if our value is smaller than 1000, we'll do the same thing that we did before. If not, however, let's connect this to our condition. So actually we need here to set up the output result of this compared to greater to something like, for example, condition attribute, and let's say we'll get attribute. So get attribute from point index, and the attribute will be condition. The index will be 0. So let's connect it right here. So because right now our condition is met, this will output from our branch here to output B. So in our output B, let's set attribute, and the attribute we'll set is our grammar, and we'll set it to, for example, we'll append string, and the string will append, for example, will be window and then comma, wow, and again the star sign. And let's connect this. So we'll set the grammar to this new value, and we'll continue to our subdivide spline. We have a warning, invalid repetition value window. So here, yeah, we need to put a comma before the window. Okay, great. So right now, if I make my spline shorter, so it is less than 1000 units, which is what we are checking here. It will only place wow segments until possible, because of our grammar string is just set to wow and then a star sign. Then if I make it longer than 1000 units, it will append to this string, this new string, so comma, comma, window, comma, wow, star. The result will be wow, then star, then window, wow, and star. So this means that it will place however wows possible, then window, and however wows possible at the end too. So as you can see, this makes it that it repeats some wows, and in the middle it places a window. And we can make this a little bit more interesting by adding a random for the type of the wow. So either would be a wow or wow2. And let me show you how it looks. So it's curly bracket, then wow, comma, wow2, closing curly bracket, and then star. And here again, let's do it actually like this. So we'll add window in the middle, and then we'll append the same string that we have here into the beginning, so we are sure that it's always the same, like this. So right now, if, for example, we don't want to be a random wow or wow2, we want always to be wow2, we can change it on one place, and it will change before and after this window. So by doing this kind of conditionally changing the grammar string and setting it up with an attribute, you can control with logic inside your PCG graph how your grammar is changing, and the grammar will control how you're splitting your spline, setting up different type of meshes for every segment that you want. And you can have a lot of segments, and let's go back to the other example. So let's place the train right here. Let's mark generate mode, okay. So as you can see, let me do it a little bit longer. So as you can see, I'm doing the same thing right here. So if the train is smaller, I have 3 doors right now, but if it's longer, I have 4 doors. It's done exactly the same way. If it's more, we have 2 doors only. And again, the meshes in between, as you can see here, we have a wider wall without window. Here it's a shorter wall without window. I have a door, I have white window, I have this narrower window. So different type of meshes all around. Again, here for the wheels of the train, probably they're not called wheels, but I don't know much about trains. But here you can see we have 2 set of wheels. If it's longer, we have 3. So again, the same thing I showed you before. We have a random amount of these objects for the undercarriage and random type. So we have these big boxes, we have these smaller boxes, and so on. So it's the same logic. And an important note for this pack in particular, or all the packs that you have where the pivot point is not in the middle, is that you need to change a little bit the logic, so it will not be so simple as with meshes which are in the middle, and I'll show you right now how we can fix this. So let's go back to our example from earlier. So let's delete this train, And let's go back to our tutorial graph. So here, our modules, which we have connected here, have their pivot placed in the middle, but let's go to the actual meshes from the pack that we have. So let's connect this 150 wall right here, this 200 wall right here, and this window 150 units right here. And you start to see that the meshes start to not align with our spline. First of all, they don't start where our spline is, they start before the spline. They don't end where our spline is ending. And in the middle we have some gaps into some areas. And this is all caused by the pivot of these meshes, because the pivot of these meshes is in one of the sides, it's not in the middle. And let's see how we can fix this. Let's first change again to have random wall. So we can see all the segments in our example in the level, like this. So we have the smaller wall, the bigger wall, and the window. Okay, so let's see what we can change in order to fix this problem. So the problem is that the grammar expects that we are placing the meshes from their middle part, but the actual pivot of our meshes is not in the middle. So after this match and set, we need to get the size of our objects and calculate how much we need to move them. So we need to move them half of their size. So to get half of their size, let's inspect this match and set, and you will see that the grammar will automatically get the size of your object. So here we have a size set up 200 for the wider wall and 150 for the shorter and the window segments. It will get automatically the size and apply it to the bounce min and bounce max into the X direction. One will be negative and one will be positive. So in our case, let's take, for example, the minimum one, and let's copy attribute. So let's copy the attribute, which will be $ bounce min, and we'll copy it into center. Let's inspect this. Let's connect this again. Okay. So right now we have our center X, Y, and Z, and our center X will be minus half of our size. So in order to move our object, and let me show you first the wrong way of doing it, and later I'll do the proper way. So first, in this particular case, we can use an add, and then we'll add to the $ position dot X, we'll add the center dot X, and we'll output into the source, which means this position dot X, and let's connect it right here. And we actually need to move it to the other side, so this will be bounce max, not min. Okay, and as you can see, this looks like it fixed our problem. So it will take half of the size of our object and it will add it to our current position.x. But the problem with this is if we rotate our object, it will not work properly because we are adding to the position x of our point. And we actually need to add to the relative position to the point. Something similar to what the transform points is doing. So these transform points, for example, we can use it right here. And I'll show you another method again later, but just so you understand what we are doing. So these transform points can move your points relatively to their position. So if I rotate them like this, and if I put an X offset, for example, of 500, you can see that it's always moved into the same direction. It's not moving them into the actual X position in the level, but to their relative X position. And this is what we need to do. And to do this, let's delete first this transform point, and we will use transform direction node. And let's connect our points to this, and the inputs will be the center attribute that we had, and the input source 2 will be the transform attribute of our point with the $ transform. Then we'll add our $ position to our center, and let's connect it right now. And you'll see that now it works no matter how we rotate our train. And okay, so let's see how we can use the objects that we spawned already in order to spawn different objects. So first, let me make so that we have the interior version of this spawned on the other side. So we don't have just this exterior wall. So let's make another parameter, which will be called modules interior. And it will be of the same type of str then tutorial, which we created. And it will be again an array, and we'll have again 3 elements. And these 3 elements will match exactly the ones that we had before. And in this way, we can use the same grammar, so we are sure that they match. So we have wall, which is 150 units, then wall 2, which is 200 units, and then window, which is again 150 units. And let's match them with the actual meshes. So we have a window, which is interior window, which is 150. Now we need interior wall of 150 and 200 units. So we have interior wall of 150, but not 200. Let's search for interior. Yeah, it seems that this pack doesn't have a mesh of 200 interior units, so let's use 2 of these meshes and let's merge them. So actor, merge actors, and I'll call it sm underscore interior wall 200. And it will be into the same folder that we had the other meshes. So let's see. The pivot is at the start, and we want it on one of the sides. So let's edit the pivot into modeling mode. And by the way, this is how I edited the pivot to be in the middle for the other meshes. But right now, in order to have the same workflow, I'll just edit the pivot to be the same as in the other meshes. So let's save this. And let's go back into our regular mode. Let's go back to our PCG graph for our tutorial. And here, let's connect the interior wall of 200 that we just created. So let's search for interior right here. And hopefully this will work fine. So let's save everything. And right now, let's use the same graph that we already have. When we are splitting our spline, let's copy this and let's use our modules interior instead. So here we'll connect our branch and our set node here. So the A and B outputs of our branch to a new subdivide spline. And match and set. And after this, it should be the same for all the other nodes, hopefully. Yeah. So right now, we are splitting the spline once for the modules of the exterior, once for the modules of the interior, and then every manipulations that we do is the same. And in order to have the beginning and the end of the train set up, let's get our points that we have for the spline right here. So this is the first and last point of the spline. So the way that we calculate the size of the spline is with this filter, this filtering the last point of the spline into the inside filter and the first is in the outside filter. So we'll use these 2 points, and let's actually first use the outside point, and we'll connect this to a merge node, merge points, and we'll merge it with the other, but first we'll transform the other. We'll rotate it 180 degrees because we want to spawn the beginning and the end of this train. And the beginning of the end of this train is PCG data asset. So it's an instanced level, and you can watch one of the previous tutorials. I believe it's not the last one, not the last 2 ones. So 3 tutorials before this one, I believe, is the tutorial for the level instances. It's the same approach as we had there. So we'll copy our points from here to the first and last point of our spline, and then we'll connect this to the static mesh spawner, which is set up already to spawn the mesh attribute. So as you can see, it works fine. We just need to move the points that we spawn from here. Let's do transform points and we'll move them. Yeah, something like this. Now we are placing at the 2 sides our ends. We are placing this wall. And let's see how we can place objects based on this wall. So I'll not create the door, for example, but I'll assume that this is a door and I'll add the railings next to this one. So how you can place objects based on the generated points from your grammar string. So if we go right here and do attribute filter, and into this attribute filter, let's say we'll find where our symbol variable is equal to a string, and the string will be called window in this case. This will find all the points where we have this window placed. And for these points, we want to do a static mesh spawner, and we'll spawn, for example, this railing. Let's find it and connect it. This one, for example. So let's create a mesh entry, and into the descriptor, let's connect this, and let's do a transform points. And this railing, let's move it a little bit, -50 in Y. So something like this. And 50 in Z, or 30. Yeah, 30. So something like this, and probably scale it to the other side or move it to the other side. For example, minus 150. Yeah, so it's on this side, it's not in front of our door or window in this case. So by filtering our points with the symbol that you know it's placed by the grammar for each object. So let's change our grammar so we have two windows, and you can see that for both windows it will place this railing. So let's go back to our grammar right here, and let's say we'll not place only one window, but window, then wall 2, then window again, something like this. And now our grammar is adapting our spline. And actually you can see we have some gaps in places. And this is because here where we moved our objects, we did not consider that they're scaled. So their size is set up, but they actually have some scale into the X direction. So you can see it's a very little scale, 1.081, but again, it's still changing the size. So after we copy the bounce max to the center attribute, let's do a multiply, and we'll multiply our center.x. We'll multiply it by our scale.x, and let's reconnect here, and this will get rid of these gaps. Yeah, and as you can see here, every time we have this window placed, it will place this railing as well. And let's see one last thing for grammar, which is pretty important, is how you can use grammar to separate vertically your objects. For example, if you want to create a building where each floor is different, you need to be able to create a grammar for this, because it will be much easier than using regular PCG. So let's go back to our grammar graph, and here when we are getting our spline, let's do duplicate cross-section node, and this duplicate cross-section node will duplicate your spline, and it will output a separate spline for each module that you set up here. So because we will not spawn the meshes directly from this spline, we'll subdivide them later as we had it before already here with our subdivide spline. We'll just use this module info directly into this node, and let's say we'll have first floor module, and the size will be 300 units, for example. Then we'll have middle floor, the size will be again 300, and let's say we'll have last floor, and the size will be 300 as well. And here a very important part is into what variables these values will be output. And you don't want to do the same as you had before, so it will not overlap the same values. So let's say the size attribute here will be height, and the scalable will be scalable floor, for example, just to be sure that you're not overwriting the same. Okay, so when we duplicate cross-section our spline, let's connect this to our regular graph as we had it before, and let's see what happens. So first we need to add some grammar string right here to our duplicate cross section. So let's see, our logic will be we'll do a first 4, then middle 4, and then last 4. So as you can see, it split our, actually not split, but repeated our graph based on this logic. So for example, here, middle 4, if we group our middle floor with the square brackets, like we did before, and then add, for example, 3, this means that we'll add 3 times the middle floor, and our extrude vector currently is 1000 units. Let's do 2000, because if we want to put first 4, then 3 times middle 4 and last 4, this is total of 5 floors. Each one is with a height of 300, so 1500 total. And this is why we need to have our extrude vector bigger than this value. Or actually what we can do, instead of telling it to do middle 4 3 times, we will put a star, and then by controlling this value, it will fill with middle 4s our multi-story train, or the actual building that you are creating into this way. And the good thing is that when you duplicate this cross section, it will create a separate data set for each one of them. So you can use them later in order to place different meshes, or merge them and use this symbol to split them with some filter in order to place different meshes on the first or last floor, for example. So let's say that our first and last floor will have windows, but the other middle floors will not have windows into our train. Let's see how we can edit our graph so that each floor is different. Or let's make the first floor different for this example. So after we duplicate our cross section, let's filter. Let's, instead of having this logic for our grammar, let's delete that, and let's filter data by attribute. So filter data by attribute. Let's check for attribute called symbol, and let's check if, let's change to by value, so symbol, and let's check if it's equal. The constant threshold will be string and first 4. So for the first 4, we'll add attribute grammar, which will be, let's say, wall, and then star. So it will repeat only walls. And for the other 4s, which are not equal to our first 4, they will have a window and then star sign to repeat window for their grammar. So we'll add different attribute grammar for our first 4 and the other 4s. And let's connect to our exterior and interior graphs both 4s. And now you can see we have different grammar for the first 4 and for the rest of the floors. And in this way, you can easily create buildings with different placement of their meshes for each floor. So hopefully this helps you to understand how to create different setups with grammar. And so we are repeating the same logic for this kind of door steps are placed everywhere where there is a door, the same way that we placed this kind of railings inside. The seats are placed when there is a window with 150 units size, or the regular interior wall with 150 units, and so on and so on. So all the other parts are just the grammar string. So grammar string for the wheels, then random object of this undercarriage objects, then wheels again. So repeat the same logic for every part of our train, and you can have this finished train just with this simple approach I showed you with grammar. So if you like this tutorial, and I'll appreciate it a lot if you like the video and subscribe for the channel, you can join the channel, and into the higher levels you can watch the videos earlier and get your questions answered earlier, and it will help me a lot in order to continue to create tutorials. Let me know what kind of tutorials you want to see in the future, and guys, I'll see you in the next tutorial. Bye!